Okay, so today we will start with the backtracking problems. Uh, so let's pick the first problem, which is subsets. Okay, so basically backtracking involves a recursion. We recursively try every path and we backtrack, means we recursively try a path, then we backtrack that path and again. So basically all this thing we will do recursively. So what we recursively do, we recursively try a path to find the answer, then we came back from that path. Basically we backtrack that path and then we try another path. Means backtracking we try all the possibilities. That is why the backtracking, whenever you see a problem with the smaller constraints, basically the input constraints are between greater than 0 and smaller than 20, so we can estimate that this is a backtracking problem. So backtracking problems are exponential in nature, so 2 raised to the power n, we can say, if we have two backtracking paths. So that is why there always a small input is given in the case of backtracking problems. Let's read out this problem. So this problem says subsets. So given an integer array nums of unique elements, return on all possible subsets the power set. The solution set must not contain duplicate subsets. Return the solution in any order. So basically we are given an array and we need to return all its subsets. So empty subset is a subset, 1 is a subset, then 1 2 is a subset, 1 2 3 is a subset, then 2 itself is a subset, 2 3 is a subset, 3 itself is a subset, 1 and 3 is also a subset. So here as we can see, the constraints are between the length of the array. The nums array is greater than 1 and it's smaller than 10, so constraints are within this range. Means this is a rough estimation to identify the backtracking problems. So here, as all the paths we need to traverse, that is why the constraints are small. So basically all numbers are unique, so we need to find all the subsets. Okay, so what we can do here is we will call a utility function. Let's say we call a utility function on nums array and we start from 0th index. We see if our index idx becomes equal to the length of the array, then in that case we have nothing to iterate, so we can return. Now what we need to do is we need to uh, initially our index is 0, so we need to decide whether we want to consider this element or we don't want to consider. For example, in this subset we have considered this element, means we want to take this element or we don't want to take this element. So let's say we don't want to take this element, means we want to skip this element. So suppose we take a array list also as an input to collect whatever we have taken till now. So let's call this list as current set, means our current set. Okay. Also we need a array, means a list which we need to return at the end. So let's call this as power set, and we can initialize our power set here itself. So power set equals to and we can return power set at the end. Okay, so what we need to do here is we can means choose to not to collect this element. So in that case what we will do, we will call our utility function, means we are this function is calling itself. So when a function calls itself, I think that is called recursion. So it will call itself with nums, and we will increment our index that we have skipped this element 1 and we are moving to next index, 1th index, and there are no changes to our current set. So basically this call represents a skip, that we have skipped the current element. Now we have this second call, we can take a element. So in that case, if we take a element, what we need to do is we will add that element to our set, current set dot add nums of idx. So we have added that element to our current set that we are deciding to choose this one. Okay, and we have chosen this one, and we can call our function further to collect our remaining elements idx plus 1, and we will pass this current set. So this current set I have passed will contain this index. Once all the calls to this function completes, so so when will calls to this function complete, when it reaches the return statement. So it reaches the return statement, so after that this line executes. So in one try we will not add the current index, and in another try we will add that to our current set. So we have added it to current set. Now suppose we have added 1. So after all the calls after this, the 1 will be considered in our call. But we also have a set where 1 is not contained. For example, here 2, here 1 is not contained. So what we need to do here is, we also, after this call executes, that all the sets which contains 1 are found, we can remove that from our current set. So 1 is added at the last index. So what we can do, we can remove current set dot size -1. So basically this is the last index. So we will remove it from the last index. Okay, so at the end, when we reach this condition that we have iterated our whole array, then what we need to do is we need to copy this array. Means we need to uh, copy this list and put it into our power set. So how we can do? We will do power set dot add new array list, and that new array list will be a current set. Basically this will add a copy of the current list. So let's try to run this. Okay, we have got some issue. We need to make this as capital. Let's run this now. Okay, we again got some issue. We need to add a T here. Okay, so we are getting correct outputs for both cases. We can submit it. So this is our solution. So these will be my previous solution will also be same, I think. Okay, so this is the same solution. So this is how backtracking works. Means we add an element and we then uh, try all its path, and then this step is basically backtrack. Means we will remove the current path, means which we previously traversed. So this is basically the backtracking part. Otherwise it's recursion. So let's see another questions to clarify approach. Okay, so we already have a pasted solution here. When the last we have solved this problem, let's see. We have solved it in June itself, so we can solve it again. We can reset our code. Okay, so this was the problem which I was got asked in my interview. Basically we need to find all the okay, we have a given array distinct integers, candidates, and a target integer. Okay, return the number of all unique combinations of candidates where the chosen number sum to target. You may return the combination in any order. The same number may be chosen from candidates an unlimited number of time. Okay, so here we have this array and we need to find combinations, means numbers whose sum becomes equal to this target, and we can choose a number multiple times. For example, this a sample output, we have taken this two times, 2 to 4 and plus 3 is 7, so this meets our target. But I was asked a problem where we can choose a number only once. So two combinations are unique if the frequency is at least one of the combination number is different. Okay, so our target will be less than 150, and our total candidates length is smaller than equal to 30, means we can see our input range is pretty small, and value is greater than equal to 2. And our target is smaller than equal to 40. Okay, so the same pattern we need to follow here which we used in previous question. Okay, we need to return a list of integers. Let's define that list. This will be our answer. Let's define our answer as the new array list of nothing. Okay, let's call our utility function which will take candidates. Okay, and a target, and our current list, means current output, current path, and at the end we will be returning our answer. And one thing we can do here is to that initializing variables globally is not considered as a good practice. We can also pass this variable into our function call also. So let's define answer here and pass the answer here itself. We also need a index variable, that where we have reached in our candidates array. So let's say we initialize our candidates array as array, and this is our index, and this is our target, and this is our list of integer, our current path, and this is our answer. So if our index reaches at the end, we need to return. Okay, now what we need to do here is similarly we have an option that we can skip taking current number, or we can take the current number. So first we will skip the current number, that we don't want to choose the current number to be part of our means answer array, means to sum up to target. So first step will be skipping. We will call our utility function on our array. We will increment the index that we are skipping it. We will call our target. And there will be no change to our current path and our answer. Now we have option that we can choose the current number. So we can only choose a number if the current number, which is this, is smaller and equal to the target value. Then we can only take that number and add that number to our current path, and then we can call our utility function. And we don't increment index here because we can take a number multiple times. We could have added here +1 if we are allowed to take a number only once, but we can here take our number multiple times, so we can avoid this condition. We must avoid this condition. So we have added this, and we will decrement this value from our target. This much of our target is, we have got this much value from our target, and we will pass the current path and answer. And at the end we can remove the value which we have added from our current path. Current path dot wait a second, current path dot remove size -1 means the value which was added at the last index. Now where we need to store our answer. So whenever our target reaches 0, we can say that we have found all the values, so means we have reached our target. So in that case we can add our current path to our answer. So we have added our current path, and then we can return from here. So I think that is it for this question. So this is skipping and this is taking. Okay, so I think this looks good. Let's see if this works. Okay, this is working perfect. Let's submit it. Okay, we have got a submission. So basically backtracking have a same pattern, means we can skip a value if we will check conditions to take a value, and we will take that value, and then we can remove that value to explore further paths. So after adding this value, this call will explore whatever paths including this value, and after exploring all the paths we will remove that value and will work with other values. Okay, so this is also done. We can move to permutations. Let's see, when was our last submission? It was in August 23, nearly 1.5 years ago. So here nums.length is smaller than equal to 10, and numbers are between -10 and 20. All numbers are unique. Okay, let's read out the problem. The problem says given an array nums of distinct integer, return all the possible permutations. You can return answer in any order. So we are given this array with the distinct integers, and we need to return all the permutations, means how we can all the possibilities in which we can arrange these numbers. We can arrange these numbers into this much ways. Okay, so let's say we have this array. So how we can find all the permutation of it? We can do one thing. We can add these values to a set, as all values are distinct, and we can one by one use all the values and can pass on the set we have used. But that will cause. Okay, we can do this. Can we do this? Let's try to do. So similarly we will initialize our answer, and at the end we will return our answer, and we call a utility function which will fill our answer, utility. And what we gonna put into its arguments is nums and initial index at pr, and new array list. Let's initialize our function int idx list of integer integer current set what I am thinking is I'm thinking of using a set and in that set can we add arrays as list nums. So I think in this way we can add values to the set. Let's make this return and check if this works. Okay, this is not working. Arrays as list. We will not waste so much time. We will simply paste it here. Means we have added all the values to our set, and suppose we pass our set to this code. We also need to pass our answer and our set. So set will be set of integer set, and our answer will be this and our answer. So whenever our set size becomes 0, that means we have used all its elements and we can add answer to our answer list of list. We can add our current set and we can return. I think we don't need index. Then we iterate our set int element in our set. This will give current element in our set. So what we can do is okay, this will not work because we need to reiterate our set. Okay, this will not gonna work. This approach using set will not gonna work because we need to use all the values. We cannot skip any value. We somehow need to swap values instead of using a set. Okay, set source file. Okay, we have this index, we are also okay. Let's write the base condition. If names.length becomes equal to idx, in that case we will return. Okay, we have our index. If we reach the end, we can add that value to our current set to our final answer. So what I'm thinking is, I'm thinking of swapping the values, like we have this array. So to find all the values, what we can do is, first we can swap one with itself. So we swapped one with itself. Then we can swap one with this two. We have swapped this one with this two. 2 1. One with itself, then one will 2, and 2 with this 3. Suppose we can swap idx with I. We have swapped, and after swapping we can do is, we can call our utility function and call the next number. Instead of using current set, we can convert array to list. I think this will give us arrays as list. Let's say we use this. We have initialized a list here. And then we add that list here. Okay, we can skip and we can move to next index, and then we need to reswap that values. Okay, so it will look something like this. Nums of a and nums of a. So we have stored nums of a's value in temp variable. So now our temp variable will hold nums a's value, and nums a value we will store nums b value, and we'll replace nums b value by temp. So this is a swap function. We are swapping values at these indexes. Okay, so what we are doing here is we are swapping one initially with itself, then one with 2, then one with 3. Okay, let's see if this works. What error we are getting? Okay, initially the index will be 0. Okay, so our first test case is giving us a wrong answer. 2, 3, 1. Okay, we are not getting these two values, 2, 3, 1 and 3, 1, 2. Okay, so how we can get these two values? What's the issue we are having? Mm, what if we pass here index plus 1? Okay, but why this is working and that was not working? Initially we have swapped 1 with all these values, then we called our function for 2. Initially we were swapping our 1 with 2 and we were making I plus 1 as our next value. Okay, let's submit this. Okay, so I'm still having a doubt. Suppose after swapping this value, suppose this is our index and swapping index with this value I, then what we were previously doing, we were moving our I to this position. If we had a 4 here, we were moving I to this position, so that's where our these cases will left. So for example, for this test case, if you put a 4 here, so our test cases where the values starting from most of the values starting from 2 and 3 were getting skipped, and there is no value in our solution, I think, which starts with the 4. So this was skipping our values I plus 1, so that is why idx plus 1 works. Okay, so we have solved these 3 problems. So all the backtracking have problem has shape pattern, so we are swapping and we are reswapping, means we are doing something, we are calling a function, then we are undoing it. So all the backtracking problems have same template. So yesterday we will target these 3 problems, tomorrow we will target these 3 problems, I think. Okay, so that is it for today.